Okay, so you can actually go see these T-Rexes pretending to have sex. Whether T-Rexes had sex like this or not, we can decide later. They did happen to model both of these mounts after Stan, which is the presumed male Tyrannosaurus. So these are actually gay Tyrannosaurs, but that's okay. Most people wouldn't recognize that. Also, they don't have their rainbow shirts on, so you wouldn't necessarily know just looking at them or their chaps. But in any case, these guys are mounted in a way that I would argue is sort of a human biased view of sex. I think a lot of our views of dinosaur sex reflect what humans think about sex, right? Which is not particularly unsurprising. Humans have the most experience with sex within their own species, right? We don't spend a lot of time with other species, hopefully. But so we have to sort of move out of that, and we should probably, of course, look at modern theropods, birds, and examine exactly how they have sex, right? Now we have to be careful because I've mentioned it before and I'll mention it again. Birds have evolved specialists in flight, and sex is fine except that it often comes with additional elements like big heavy gonads, which you have to jettison if you really want to be an animal that's all about flight. And birds do this in a variety of different ways. So some birds will grow a penis but then lose it. Other birds do not have a penis. So there's lots of ways in which to get around that problem, but I just want you to keep in mind that we're going to look at birds, but it doesn't mean birds are the right answer. And the fact that birds are very, very different in the ways in which they have sex suggests that possibly dinosaurs by and large were different in the ways they have sex. So the idea that the one size fits all in this case would be relatively limited. I do like this in the background, just in case you weren't sure what's going on here. So we're going to look at some of these animals. This is Morrison Formation again. This time it's a little bit further forward within that. First thing we're going to look at are medullary bone within T-Rexes. So one of the things that birds do is they produce what is called a femoral bone in females, which provides a storage area for calcium so that they can access that calcium and coat eggs in it, right? So they make an egg. That egg has to go into an area that covers it in an actual eggshell, and when that's done, the egg is then laid out into the environment. And of course, covering things with eggshell is really, really expensive because it consumes lots and lots of calcium. So you need to be able to store it somewhere before you do that. So we're going to look at a T-Rex. I don't remember why I had this one with all the bones labeled, but they are. And we look at the femur. Oh, yeah, I know now. We look at the femur because this is the bone they sliced open, right? So one of the things that they did was they actually cut the bone open and exposed. I should have written the name here. Cut the bone open and exposed the material within it. So these are cross sections from bones. There are living ratites, which are ostriches, above, and then there are fossils down below or to the left. And let me show you the difference here. So this box right here is covering the fossil bone, and it is easier to see once you box it because you know what you're looking at, and you don't see this bright red material. Of course, the red is the actual blood vessels which are penetrated into the medullary bone and supply it, one, with food, nutrition, right, so it provides food, two, it removes waste from the medullary bone, and three, it allows access for the calcium to penetrate back into the bloodstream and be transported to a new location, right? So at the end of the growing season, or at the end of the breeding season, when the medullary bone is done being used, then it will be reabsorbed and you won't have it within that, right? So the blood vessels and all that material will break down. But I want you to see, of course, in a fossil, you're not going to get this redness, right? We're not going to actually get the red blood vessels as a bright red color within it. But what you can see, of course, is that there's this hard outer bone. In this way, there's a thin bone sheath around this. And again, it's a pneumatic bone, so there's room within it to produce this. You see that here in the Tyrannosaur. And then you see highly vascularized bone on the inside of that. And so this is, in fact, a female, right? This is a female Tyrannosaur. She had some amount of medullary bone left, so she was breeding, or I should say laying eggs. She had already bred at some point, and she probably died in the process of that. Same thing here, right? This exact same visual in this case. Oop, where's my arrow? Again, the fossils are located here to your left, and this time they take up the whole thing. I'm not terribly concerned about you spending lots of time looking at this. This comes from a paper where the authors were very insistent that it be, this is a Jack Horner paper, very insistent that this be medullary bone, and to support that they need lots of images, right, to convince specialists at large that they are in fact looking at medullary bone. So they have lots and lots of pictures. What I just want you to appreciate is that it is so similar, right? This is really the same stuff that we see in modern ratites, which means medullary bone by and large appears to be a dinosaurian trait or an archosaurian trait that extends further back. But you can see here's the fossil and here are the modern, and they are very similar. Very, very similar. In fact, if not identical in that way. So at least the breeding cycles of dinosaurs at this very simple element where there is a production of medullary bone to provide calcium stores is probably the same between birds and dinosaurs in that way. And then they also dissolved the bone, so they broke it down with, I think it's hydrochloric acid. In any case, it's a strong acid, and they left behind small amounts of the soft tissue. Remember, I told you that you can get very small amounts of soft tissue occasionally if the preservation is very, very good, and we use that to build a DNA sequence for collagen, right, in dinosaurs, and that was done fairly recently. This is partially how they do it. They broke it down, and again, this stressing the point that the fossil collagen is the same or very similar to modern ratite. So it looks the same, it behaves very similarly, it's located in the same locations, and therefore that probably does the same thing. So medullary bone is found only in birds amongst living archosaurs, so it's not a trait that we see in crocodiles, and so it appears to be a trait that is at least within the theropods. And we might even expect it to extend into other dinosaurian lineages. We just don't have that information yet. But certainly, that's a place to start, right? If you're a paleontologist and you find an animal with a nice long big femur that you are willing to split open, you would go ahead and split that open and look for medullary bone, and then you might be able to identify the sex of that animal, right? If you're lucky to have caught it during that, the laying window, basically. The amount that was actually left within this particular T-Rex means that it was almost done laying eggs, so it was probably a female. She's probably at a very stressed point in her life, right? So she's spending a lot of energy to produce eggs. She's also spending probably a lot of time taking care of those eggs, and she apparently did not make it for whatever reason and then died, and then we happened to find her. We need to look for medullary bones in other dinosaurs, and of course, this gives us information also about growth rates within them, right? If we can identify enough males and females, then you can establish different growth rates between them. And you've seen this very many times now. We're moving forward, I guess. But the point of that is that T-Rexes, again, are not sexually mature when they are fully adult. They're sexually mature before they're fully adult, and then they extend that into an adult period. So this animal probably died at the end of the what we think of as the breeding season, the beginning and sort of the end of the laying season, where these animals are producing eggs, which probably means there were a number of little T-Rex eggs which were not protected and were therefore eaten. And then on top of that, it makes sense in the sense that this animal is probably under a lot of stresses at this point in its life and is probably very vulnerable to things like disease, right? Which is a common problem for animals. And we might expect things like, when does T-Rex lay eggs? Well, probably when prey abundances are going to be high. So it probably produces lots of chicks just before things like the wet season would roll around. The chicks are right there when everybody else arrives, or maybe lays eggs just after the wet season has started, and so that chicks are hatching out when other small dinosaurs are already around for them to feed on. And this is a little bit after your time, but so that is the one section of, or a little bit before your time, but that is the one paper that's up there, again, relatively short, and I think that you will find it fairly easy reading. And then there's another paper that is more for the layman, which talks about what's called Love Among the Dinosaurs, right? It talks about some of the difficulties of breeding. I've already mentioned to you some of the issues of breeding, which are sort of self-evident when you deal with dinosaurs. We're going to talk about that a little bit here in a more complete manner. The question the paper asks, the question that I think a lot of people would like to know is, how do dinosaurs actually breed, right? It seems very hard to imagine a dinosaur actually going about having sex. So, of course, we want to look at birds. because birds provide us with a lot of information. So what's actually going on here? So this is actually how a lot of birds breed in a similar fashion to this one. And it's a little bit difficult to imagine all dinosaurs doing this, but the male actually stands on the back of the female, right? And so there is, in birds, that's not a real big deal because the animals are small, and so it's not terribly concerning that another small animal be on your back. But you can imagine some of the differences and difficulties of this if one, you have large animals, right? Large animals staying on the back of other large animals is pretty dangerous, not least of which because you can snap each other's backs. Two, if you have a tail, right? Notice the angle of the tail here in this female. So the female would have to hold a tail vertically to allow, and off to a side to allow a male to position himself. And in this animal, it's a very, very small tail, so it doesn't get in the way. But if it was a large tail, it would actually get in the way. The way the male would sort of have to be off to the side, and the male, on the other way, has to be able to balance himself with his tail out to the back. And three, if you don't have feathers, right, those claws are going right into your back. So you got to have pretty tough skin to deal with that, because especially for things like male theropods, that would be a real issue to have a male theropod with nice big sharp claws on your back. In that way, if you're a female. And that makes, at least for theropods, right, this seems to be reasonable to a degree. But if you imagine other things, like other quadrupeds, then you start to get into questions about how do you actually orient animals so they can actually meet each other. So what's actually going on here, if you were to be able to lift the bird, the outside of the bird up, like those little flip books where you could flip part of the body away, it would look something like this, which is a situation in which the testicle actually, there is no penetration by the male into the female in this case. What's actually happening is that the male is releasing sperm into the cloaca in sort of a package. The cloacas of the female and the male are pressed together, and then the male forces a sperm out of his cloaca, and it collects into the female cloaca in this case. So it's not, if you see bird sex, you will be surprised, one, at how fast it is, right? It can be like that. It can actually be almost so fast that you can't see it, and two, also by how unimpressed both animals are apparently by it. And that's because often it's something like this, where the animals literally are just almost touching butts in that way. In that case, a cloaca is really, it's a universal exit pore. It's a primitive feature found in many animals, right? Fish have cloacas. Or I should say primitive lobes-and fish, of course, have cloacas, as do things like sharks, so it's a very old trait. And in this case, the advantage of being able to, or what's actually going on is they're just meeting together just enough to allow that transfer. And so all the animals actually need to do is just touch once. And so animals can do it very, very rapidly. There are all sorts of interesting ways in which males and females compete in this environment. So remember that an individual is not concerned with another individual's well-being, only with its own. And so if it's helpful for the individual to persist and assist the other individual, then that is what will evolve. But in many cases, individuals have alternate goals, and so females may or may not want to breed with just one male, and so there's all sorts of very interesting strategies. Things like swans, of course, will defend each other, right? But they are males are defending females not because they love a female. They're defending a female to prevent access by other males, and they will very aggressively go about, preventing her from getting access to other males, and also preventing males from getting access to her in that way. So this is a common strategy amongst birds. It's called the cloacal kiss. I don't know that it's that pretty, but the actual contact of this, again, is a very simple maneuver. Although keep in mind again that birds do not have the big tails that we deal with in dinosaurs. It's very simple to move a tail that's only a fifth or smaller of your body out of the way to get access to the cloaca of another animal. It becomes a little more difficult when the tail is the length of yourself or more, right? There are some issues with that. Ratites, which of course are the ostriches and the emus, but you didn't expect to see an ostrich penis so early in your day, because it's always early, the ostrich penises. But ratites have penises. I think it's penises. It might be penum. But the penis is used in a very similar manner to the way it's used in mammals. The difference is that the animal does not. Again, mammals have this very elaborate sexual courtship ritual. Often males will have erect penises. before they have sex with males, right? That's the joke. That's why when the dog comes over to hump your leg, you know it's about to hump your leg before it gets to you. Ratites are a little bit different. They will expose the penis only when they're literally about to breed with a female, and so you very rarely see it. But it is also very, very long, usually. So these ones, they look short. The penis can be very, very long on an animal, and that's because female oviducts can also be very, very long, and male ratites are trying to get as close to the egg as they can because they're competing frequently with other males. And so the closer you can get your sperm to the actual location of the egg, the better chance you have of fertilizing that egg before another sperm meets it. So those penises are exceptionally long. Penises are filled in this case with lymph fluid. In mammals, it's filled with blood, right? It follows the way that things like Viagra work is they allow you, if it causes blood vessels to dilate, which causes penises to become erect in mammals, right? But in birds, that would not work very well because birds use lymph fluid, and so they push lymph into the penis very rapidly, and then they remove it again when they don't need it to be erect. Again, this is fully protected within the cloaca. So the cloaca, if you were to just look at the animal, so if you just look at the back of the animal, like you would your cat when it always looks at you from the back end, if you just look at the back of the animal, it wouldn't look particularly different to you in the sense that you wouldn't be able to say, well, that's obviously a male, right? You can do that with mammals by and large. You can say, well, that's a male, very clearly. This would be recessed within the cloaca, and again, only when it's about to actually make contact would it be pushed out, and then at that point, but that's definitely a male in that case. But the important thing to note here again is that there is still mounting on the back of females, but the use of this element is very, very different. Penises have also evolved in other groups. There are ducks that have penises as well, and they can be all sorts of crazy shapes because it also turns out that the vaginal tract evolves in concert with penises. So males are often trying to, again, get closer to access female eggs, but females may not want every male to have equal access. So some vaginas in things like ducks can be corkscrewed, they can have dead ends, they can they can twist around and backwards on themselves, so that it gets harder and harder for males to get access to the actual location unless the female waits very patiently for him to set up. And so that's it. That's these sort of weird, convoluted ways of going about having sex are sort of interesting. You can if you're really lucky. So we can guess now at least that maybe dinosaurs had penises, or some of them did. Maybe some used the cloaca to cloacal contact, or maybe not. But sometimes, very rarely, you get actual contact between animals that were breeding at the time that they were buried. This one above is a very famous fossil. It's two turtles actually having sex when they die. This is a female and this is a male. And then the one below is also very famous. This is not the fossil, but it's the reconstruction of the fossil. It's a male shark. Is it a male shark? I think it's a male shark holding on to. It's either the male shark holding on or the female shark holding on to this extension from the head just prior to them actually meeting. Again, sharks use claspers, and they apparently have done this for a very long time, if not the entire length of shark life. So these animals are sort of captured. So the question about what is that weird head extension for? Is it for wearing additional hats? The answer is no, it's not for additional hats. It's for having a buddy hang off of you just before you breed with them, which is still pretty weird. And so if we look at things like ostriches, remember these guys do have penises. This over here on the right, the slightly more colorful animal, is the male. The one on the left is the female. These animals breed in a harem, but females, there is a dominant female as well. And when she breeds her eggs, they put all of her eggs in the center of a pit, and then they surround her eggs with less dominant females, and that allows less dominant females lower breeding success it provides those animals lower breeding success because those eggs are very vulnerable to predation when the adults are not able to scare away predators, and the adults are constantly guarding eggs, and they have to not only do they have to guard them, but they have to keep them often from overheating. That's another element. So the adults have to sit on the nest, and they do exactly what you saw with that oviraptor, where they extend the arms around and over the nest to keep the sun off of the eggs directly. And that's a very long-standing breeding method for these guys. Oh, I forgot to put this up. So these are the male and the female, and males mount females in a similar fashion to what you saw other birds, but again, they have a penis. Now, if a male breeds with a female, but he is beaten by another male, he will be forced to leave, of course, or die. He'll be forced to leave, and then the now dominant male will again breed with the female when he's gone. But the similarities here, I think, to the other things that we saw, there's still a male sitting on top of a female. Now, because of their size, the female has done something a little bit different. She's flattened herself to the ground to help disperse some of those forces as well. So we might think some of the larger dinosaurs can also do things like that. If you get into quadrupeds, unfortunately, we have theropods, right? It becomes much, much harder. In quadrupeds, we're stuck with a mammalian version of breeding. And again, mammals are very different. They are similar, but I warned you before that even a penis is not a conserved structure, right? That is a novel structure within these animals. And so if you look at an animal like this and say, well, that'll be a good proxy for dinosaurs, you need to be a little bit cautious, because we don't think that the structures that it's using are the same as the structures that those animals were using. There's all sorts of issues associated with quadrupeds, right? Obviously, you can guess who the male is in this case, because we're very comfortable with mammalian breeding. But one of the elements that's important is that these animals position most of their weight onto their hips. So in this case, you can notice almost all of the male's weight is directed over the female's hips and over a bit over his own hips, so that she has to be able to sustain a lot more weight that will suddenly arrive, right? Because a male is not going to sort of put one arm up and wait for her to get settled and then put the other arm up. But the weight differences here are not dissimilar from the issues that dinosaurs would have had. There are some big differences, however. Elephant tails are very small. You can just barely see that elephant tail. So no male dinosaur is going to be able to mount a female just by jumping on her back. She's going to have to be able to move her tail to the left or to the right at best, assuming that he lands squarely on her back. If he doesn't, if that's not the way in which they actually did it, then they might have to mount each other from the side in that case, because a tail would need to move out of the way. And you can imagine for things like sauropods, where a tail is as big around as something like a tree trunk, you're going to have to maneuver that pretty good out of the way to get access, which is not dissimilar from what crocodiles and alligators do. Males will grab and hold a female, and then they sort of have to they use their tail to pull her tail to the side, and then they have what are called hemipenes, which again are not a penis. It's another modified structure that is exposed from the cloaca, and it transfers sperm from the male to the female, but in this very similar fashion to the way in which a penis works. The difference with crocodiles and alligators is that their hemipenes are always erect because they're supported with cartilage. So they would never need a Viagra, right? Because cartilage would always keep their penis supported. Actually, there's some debate about whether the problems with erections in humans might be female selected, in that they select for males that are able to produce erections, right? There is actually a cost to doing that, because in some mammals they actually do have what are called erection bones, which are actually physical bones that keep the penis erect, because that would be really useful in that you would never need Viagra in that case. But just keep in mind some of these sexual selection processes are going on as well. So we have a number of different strategies which are available to dinosaurs, at least something like a cloacal kiss, possibly a penis, maybe modified in a variety of different ways, maybe something like a hemipene, but all of them, of course, are dealing with some large problem, and that is that you're getting to very, very large animals, and unfortunately, none of our current models are very good for that, because we don't have any models with really big tails for large animals that are fairly active, right? We just don't have that in that way. The best thing we can probably do is look at crocodiles and alligators, but again, we already know the archosaurs appear to have a lot of different ways to go about breeding, and so we might anticipate that looking at just one model is not going to be sufficient to understand a very diverse group like dinosaurs in that case. And then we already talked about the appearance of things like sauropods, but I just wanted to remind you that large animals that are visual animals that spend a lot of time assessing each other based on visual appearance will probably be relatively colorful, because they're not concerned with being seen by a predator. And so that may also be important as well. Having extensions off the body may have occurred, or semi-soft extensions off the body may have occurred as well, and so that also may have contributed. And the other thing that we might look for, of course, in things like sauropods or very large dinosaurs, is females may have very, very overly, or apparently overly built pelvises and hips, right? Because they might need to support about 2 animals worth of weight suddenly. So we might expect to see that as well, and so that might be something we need to look for. That works fine. And then I warned you that there are things like this that make no sense. I don't know how animals like this breed. There's a lot of problems here. One, males are definitely not going to mount on the back of this female, right? They're going to impale themselves. Two, if they lie next to each other, then they kill each other because they will poke each other in the side of the body. So how do animals like this go about breeding, right? Spines are really nice at keeping animals away, but when you want to have sex, it's not great to be covered in spines. That doesn't work very well. You need to get somebody else close to you.
And didn't animals like these not move? They weren't able to move their tails up and down the way.
They would have been able to move to some degree. They would have been more flexible than some of the stiffer animals we've seen, but they would have been more restricted than the most flexible tails we've seen. I would not expect this tail, for instance, tip to be able to come around and touch the body. It would be much more restricted than that.
Is there any evidence that they couldn't reproduce similar to the way some amphibians do, where they just deposit eggs and
So
sperm and...
the problem becomes for dinosaurs is that once you have a shell, you can't a sperm cannot penetrate into the actual egg itself, and so this is why you coat the egg with a protective casing only much later and not early in the breeding cycle. So the answer to that is no. Dinosaurs are going to have to get the problem for them is that females are producing eggs within the body, and they are going to have to meet that egg in the body before it's exposed because that's before the shell's on it.
Can you consider them mating the way whales do, where they have like a movable prehensile penis?
It's possible. Prehensile penises, of course, make. I argued that last year that prehensile penises also may be reasonable. If an animal can't get more than 4 feet to another animal, a male could very easily, be selected for having a penis that becomes relatively prehensile. One, because it speeds up the number of copulations he gets, and two, because it means that he's not likely to bump into her and get speared. So there would be pressures for that. So stuff like this, where you think about, armor, that would evolve very easily. Armor might evolve, but it will have to evolve in concert with the ability to breed. So there's a lot of different pressures going on simultaneously when you think about this stuff. So just keep this in mind when you're thinking about animals, and especially dinosaurs, and how they might have actually had sex. They clearly did it, and they did it very well because there were lots of them. But the actual alignment of those animals is very different. And the last thing is, please be careful about assuming that dinosaurs had sex in your favorite sexual position, because that's a mammalian version of sex, not a dinosaurian version of sex. So be a little bit careful about drawing out what you think is a dinosaur sex position, right? That probably is not necessarily the case. So the next 2 lectures will be extinction. The first one, like I said, will be that video in the 90s, and the following lecture will be me lecturing on the larger body of that evidence now.